All right, good evening, Calculus 1 students. So in this video, we're going to do another example of how to figure out an infinite limit for a rational function. Now, this function is not precisely a rational function because you have like the cosine of x here that makes the top not a polynomial. But the idea is the same in the sense that the denominator is approaching 0 while the numerator is not approaching 0. And the procedure is exactly the same. However, there is a difference. And the difference is in the fact that this is a two-sided limit. Okay, so it's not a one-sided limit, it's a two-sided limit. Okay, and as such, there are three possible results. So, three possible results. So these could be infinity. If both sides are going to infinity, the result will be infinity. If both sides are decreasing without bound, it will be negative infinity. And if both sides don't agree, it will be non-existent. So to figure it out, what we need to do is to compute both one-sided limits. So to figure it out, compute both one-sided limits. Okay, so we start by the limit from above, or the limit. Let's start with the limit from below, actually. Okay, so here we will have 0 from below. Okay, so what's happening? Remember step number 1, you replace 0 everywhere. So you will replace here, you'll have 0 minus cosine of 0 divided by 0. And I remind you that cosine of 0 is equal to 1. So what you will get is negative 1 over 0. Or actually, wait a minute. Yes. I will just restart this because in the first step, you actually do not need the one-sided. So the first step, you actually do it once and for all for the two-sided limit. Okay? So doing this indicates that you have a vertical asymptote. So, so let's actually put that as a remark. So step 1 is done on the two-sided limit. Then after that, steps 2, 3, 4 are done on both one-sided limit. Okay, so there you go. So this is actually step number 1, and you don't need to do it on the one-sided limit. Where you need to split your calculation in two is for step 2, 3, 4. So let's go. We have the limit as x is approaching 0 from below. Now it's the time to do it. Of x minus cosine of x over x squared. Okay? Now, I should mention here that there's no need to do step number 2 because this is already fully factored. Okay? So, I will say this. No need for step 2. Go to step 3. Okay? So then what we do is we replace 0 still. So we know that it's going to give negative 1. And then this is the factor giving 0, remember? So what we do is we plug in 0 minus. And then what we do is in step number 4, we look at the overall sign. But before we do this, let's take a look at this number. So what's inside here, the 0 minus, is a negative number. However, as you square it, it will become a positive number. So in other words, you end up with negative 1 over 0 plus. Okay, so this 0 plus over here is after squaring. So you square a negative number, you get a positive number. And then in step number 4, you look at the overall sign. Okay, so as you can see, the overall sign is negative. So let's put it this way, overall negative. Because you're dividing negative 1 by a positive number. So the answer here is negative infinity. Okay, now I need to erase this in order to do the other one-sided limit. So I'll erase this. So we now have the limit as x is approaching 0 from above, and I'll just recopy the expression, x minus cosine of x over x squared, and x is approaching 0 from above. Okay, we're doing step number 3 directly because step number 1 has already been done, and step number 2 is not necessary because this is as factored as it could be. So again, we have negative 1 over, and then we're going to have 0 plus squared, okay? And before we're doing step number 4, let's keep track of this sign over here, okay? So the 0 plus squared. So you have a positive number. Remember, this is like, it can be like 0.001. Eventually, it's going to go to 0.00001 and so on. But it's going to remain positive. And as such, when you square a positive number, you will also get a positive number. So in other words, you will get 0 plus, and this is, and I want to emphasize that this is after squaring. Okay? And again, like step number 4, because this is overall negative, you will get negative infinity. So let's have a look. Let's write the conclusion. Okay. Now have a look. The limit from below is equal to negative infinity. And the limit from above is equal to negative infinity as well. So as a conclusion, the limit as x is approaching 0 of x minus cosine of x over x squared is equal to negative infinity. And the reason is because the one-sided limits match. And this is the final answer to the problem. All right, hopefully this is helpful. Okay, so this is the last example of a rational function. I told you it's not strictly rational because of the cosine, but the denominator is a polynomial, so it works the same way. In the next video, we're going to talk about logarithmic functions that, as you know, also have an asymptote. So we will see how to figure it out with a motivating example. See you there.